I'm part of the support team. My name is Braden. If you guys have called into support, you may have spoken with me before. I am located on the West Coast. I'm over in the Oregon office. So if you call later in the day, you're more likely to get me. So for surfacing tips and tricks, if you guys attended the webinar last year, this will, for the most part, be review. I have a new example added at the end here for those of you that work with imported sheet metal parts. So let's go ahead and jump right on in here. We're going to kind of go over what we're going to cover. So first, it's very important for us to define what a solid is in order to better understand how we can switch between solid and surface geometry and how we can use surfacing to do that. It's also important for us to identify when we have surface bodies in SOLIDWORKS. We're going to go over a very useful surfacing command called delete face and the various things we can do with that. We'll go over a workflow example of creating a simple electronic shell casing, going through the delete face, swept face, trim, and then thicken commands. And then lastly, we're going to go over an example of an imported sheet metal part that we may want to get the flat pattern from. So as far as what defines a solid in SOLIDWORKS, first of all, you have to have your faces enclosed in a watertight placement. And then there's a very strict definition that every edge within a solid body is the boundary to exactly two faces. So you see on the left here, both face A, B, and C are all sharing edges. The green, blue, and red edges are the boundaries to exactly two faces each. On the right-hand side here, we see that the red edge and the blue edge no longer have the B face. So there is a term for this. These edges are called open edges, is what SOLIDWORKS will call them. So on the right-hand side, we do not fit the definition anymore, so this would be a surface body. So as far as identifying surface bodies in SOLIDWORKS, the quickest and easiest way is in your feature manager tree on the left-hand side in SOLIDWORKS where it shows your feature history. You will have a folder that either says solid body or surface body. And you could even have both. So you might have a part that has both solid and surface bodies. As soon as you see the surface bodies folder, you know that you have surface bodies in your part, and you may need to use surfacing. On the right-hand side, we have a tool called the check tool. This is a dialog box that I will show you how you get to it. But when you run this check tool, it's going to check for open surfaces as long as you have this checkbox checked, which is the default. It's going to report your open surfaces. And if you highlight it, it's even going to show you where your open edges are. So we're going to look at an example here for using the delete face command. This is a very powerful surfacing tool. You can use it for working on files that don't have a feature history. If you don't have a feature history to rely on for, say, deleting certain hole features or even defeaturing your part, you can use delete face for those kinds of things. And it's also useful for transitioning if you want to change a solid body into a surface body. So we're going to hop into SOLIDWORKS here. We have our part, and the first thing you'll notice on the left-hand side, as I stated earlier, we have our surface bodies folder. This one in parentheses means we have one surface body. We can expand this folder to take a closer look. The other thing that you will notice is that we have a surface imported feature here. It is very important that when working with imported geometry, that the very first thing you do is you run something called import diagnostics. So to do that, you right-click one of these surface imported features. If it is a multi-body part, you'll have multiple of these. You can right-click any of them. So I'm going to right-click this guy and go to import diagnostics. It is going to report faulty faces and gaps. So this is a good way to determine, in our case, we only have one gap. We may not know where it is. If I click to highlight this, it's going to highlight those edges, so it highlighted them right down here. The other important thing is when you do have faulty faces, it is important to get rid of those with import diagnostics. It may be possible to delete those faces later without running import diagnostics, but oftentimes that will just propagate the fault to a new face. You want to use import diagnostics to remove those. There's a button here to attempt to heal everything, the faulty faces and any gaps that you may have. Depending on where the part came from and what types of errors it has, this may or may not work. Sometimes you'll have to delete faulty faces manually in this section here and recreate those yourself. In this case, we're going to assume that this import diagnostics is not able to close this gap. Another good way to tell where the gap is, if you may have noticed already, those edges down here in this gap, they're highlighted in blue. So by default, SOLIDWORKS will highlight any open edge in blue. This is actually a color setting in SOLIDWORKS. If you were to go to your colors in your tools options, a little ways down there is going to be a section that says Surfaces, Open Edges. And right now it's set to blue. So the other thing that we could do to identify where the gap is the Evaluate tool. As I was talking before, in this Evaluate tab, there is the Check tool right up here. And it brings up this window right here. We'll just go ahead and click Check. It's going to say that we have an open surface. This isn't so much an error as it is just telling you that you have open geometry. This will also report invalid faces, which are actually problems, as we mentioned before in the import diagnostics. So it's another good way to check if you have any of those. So if I select this open surface, it's actually going to use a yellow arrow to point exactly where the open edges are. So for us to work on this part, we want to close it up and make it a solid, and to do that, we need to close this gap. Now, I already know that these edges here are perfectly straight, so it's going to be a straight shot from one edge to the other. So I'm going to use a surface command called a surface loft. So right up here, lofted surface, and I'm just going to loft from this lower edge to this upper edge. Now, this loft is much like any other loft in SOLIDWORKS, and if you did not know this, selection of your profile is very important. If I select my first profile on the right-hand side here, and then I select my second profile on the left-hand side here, you'll see it tries to connect one end to the other end. It's going to grab whatever is closest to your selection that you made with your mouse. So in this case, I don't want to twist things up. That'll cause problems. So instead, I'm going to select in the same area that I did as the bottom. And you'll see that it connects from one edge to the other edge closer to my selection. We get a nice preview. We can go ahead and accept that, and we have another surface body now. So now we have two surface bodies, our original and our new surface loft. And what we want to do is we want to combine them into a single surface body and convert that into a solid. So we're going to use the knit surfaces command right up here. Then we're going to select both our surface bodies, so our first surface body and our second surface body. Before I select my second one, notice how the Create Solid checkbox is grayed out. This checkbox will only light up for selection so long as your selections for knit surface are watertight. So as long as you form a fully enclosed space with your solids, with your surfaces, then you'll be able to create it as a solid. So we'll select the second part here. You'll see that it lit up. We'll go ahead and check Create Solid. And then we'll hit the green check mark. And now you'll notice we no longer have a surface bodies folder, but now we have a solid bodies folder. Now at this point you're probably asking yourself, I thought this was the magic of delete face. You've yet to see the delete face command. Well, we're about to jump into that right now. So delete face can be found right up here in your surfaces toolbar. And when you click on the command, you have three different modes that you can choose. So the delete and fill mode is going to delete the face and then replace that face. The delete and patch is going to delete that face and then extend the edges of the face you deleted. And then the delete is just going to straight up delete it. So say in this part you have a hole that's not supposed to be there, such as this one right here, and you don't have the feature history anymore because it's imported, but you need to get rid of that hole. You could do a simple extrude and close it up, or we can use delete and patch, grabbing these inner cylindrical edges. And when you delete these faces this way, it's going to extend these edges and close it up. So we'll go ahead and accept that, and the hole is gone. We can also do it for corners here. So if we do a delete face on these faces here, it's going to take all of these surrounding edges and it's going to extend and trim those. We can also do it for slightly more complex areas, such as this one right here, as long as we get all of the faces that we need. And you can even do more than one at a time. So I have a selection set defined here to grab all the rest of those faces. And we're going to go ahead and do the same operation, delete and patch. And in fact, we're also going to grab these center guys right here. And with that, we've kind of defeatured our part using delete face. So that was primarily delete and patch. The other thing is this was only on the exterior surfaces. The interior surfaces remain unchanged. So one neat trick we can do is we can use delete face to simply delete a face. I'm going to delete this boundary here. This is the only face that connects those inner surfaces to our outer surfaces. So if I just straight delete this face, we go back from being a solid, and now we have two surface bodies because those inner surfaces are no longer connected to the outer surfaces to the face I just deleted. So I no longer need these. I just want to close this guy back up to a solid so we can reshell it. So I'm going to right-click this surface body and use delete keep body. And this is going to delete that entire surface body. It is a feature-based delete command. So if we roll back before this delete, that surface body is back again. So it does follow feature history guides, feature history rules. And the last thing we need to do is we need to patch up this bottom here. Now, one great thing about these open edges is when they form a loop, what we can do is we can right-click any of these open edges, and we can say select open loop. And that's just going to select all of our edges for us. Now, I already know that this is a planar selection. All of these edges lie on the same plane. So I'm going to use the planar surface command right up here, which is just going to create a surface bounded by my selection. And there we have it. And last but not least, we're going to do the same thing we did before. We're going to do knit surface, grab our two selections, say create solid. And then if we need to, we can reshell the part and work from there. For now, we'll go ahead and review what we did and go to the next example. So we were able to identify surface geometry from the feature tree in the surface bodies folder. We were able to use the evaluate tool to tell us where the gap was. We closed the gap and patched it up, knitting it to a solid. And then we used delete and patch to remove some of the features we maybe no longer wanted. Now we'll go into a shell casing example. For this, we're going to use our delete face to transfer from a solid to a surface geometry. We'll use the swept face to add a bit of a bevel. We'll trim up some of the surfaces we don't need, and then we will thicken the end result. So while I could shell this to begin with to create the case, I want to create some details on the surfaces first, and those details are also going to have thickness. So it's better for me to work with just a surface geometry. So we're going to go back to delete face. We're just going to use the delete mode to delete the bottom face here. And now you'll see that our solid bodies turn into a surface bodies folder. We are now working with a surface body. Next thing I want to do is I want to add a nice bevel around the border of this part. To do that, we're going to use the swept surface command. If you've used sweeps before in SOLIDWORKS, it is very much the same, except our end result is going to be a surface body. If you haven't used sweeping before, essentially what we're going to do is we're going to take a profile sketch, and we're going to sweep it along a path sketch. I already have these sketches defined here, so I have my profile right here. It's just going to be this simple line. And then my path is this sketch right here, so we're going to sweep that line along that path. We get a nice preview of what it's about to look like. We do have a couple extra edges over here that maybe I don't want. So if I go into my options, there is a checkbox called Merge Tangent Faces. So as long as the faces are tangent, it's going to get rid of the edges between them, except in certain cases. So if I click that, we lose those two edges. Now these edges remain. This is because what this option does is if you have a particular part of your sweep that can be defined either as a flat face or a cylindrical face or a conical face, it is going to leave those alone. So in this case, these two sides here are flat faces. These two corners here are conical faces. The others it couldn't define, so it merged those tangent edges. With that, we'll go ahead and hit the green check mark for OK. We have our resulting part there. And now we need to trim things up to clean it up. So we're going to use the trim surface command. So this command allows us to cut away the parts that we don't need. There are two different modes for trim surface. There is a standard trim type, and there is a mutual trim type. For the standard trim type, we define a tool to cut other surfaces with, and then we choose which part of those surfaces that we either want to keep or remove. With mutual, all of your selections are simultaneously the target surface body for being cut, as well as the cutting tool itself. So let's start by just using the standard trim type. So we may say that I want this main body to be my trim tool, and I want to remove this outer section right here. We'll hit the green check mark. If we look underneath, what we're left with is the inner portion of that swept surface. Now we need to do that again because we want to get rid of this kind of wedge up here on the outer shell's edges. So we're going to do trim surface. Our trim tool this time is our swept surface, and this time the part we're going to remove is this wedge right here. Click OK. And as you can see, our surface bodies, we have two surface bodies. We have our newly trimmed swept face, and we have our trimmed original body that we started with. So we do need to knit those together. Another good way to tell that they need to be knitted together is we have this blue line in between the faces, indicating that there is an open edge. So we'll go ahead and do knit surface. We'll grab both of those. And you'll see that the blue line is gone. We only have one surface body, and our open edge is back at the bottom where it originally started. Now that took 3 commands to do. I'm going to delete these last 3 steps that we did, and we're going to do mutual trim this time. So we'll get rid of all of those. We'll do trim surface. We're going to change to mutual trim, and we know that both surface bodies are going to simultaneously be the things we want to trim, as well as the trim tools to define as the cutting surfaces. So with both of those selected, we're going to go ahead and remove selections. Now that we're using mutual, as we make selections, they will disappear. It will hide those, so we can better see what we're left with. And we'll go ahead and click the green check for OK. And you'll notice that we end up with one surface body. This is because when you use the mutual trim, your resulting bodies will knit automatically as long as they are able to. So that saves us a few steps. So instead of with standard trim where it took us 3 steps to get here, we just used a mutual trim as a single step. Next, we're going to go ahead and use a standard trim surface to use a sketch that I've created just to add a little more detail, some cutouts to this casing here. So I already have the sketch defined right here. We got to change to standard trim type. Grab that sketch. Now I could go in and remove each of these contours individually, or I could just say I want to keep a selection and I only need to keep the outside part. The rest it's going to go ahead and remove those. Green check mark for OK. This is what we're left with. At this point we can go ahead and add thickness to our shell casing here. So we'll go up to the thicken command. We'll grab our surface body and define our thickness. We can use this to define the direction of our thicken. I want it to go inward. And if we had other solid bodies, we could use merge result to merge our thicken with other bodies, but in this case it's the only one. With that, our shell casing is finished. So just to review, we used delete face to transition from a solid to a surface body. We used swept face to add a little more detail with a beveled edge, and then trim surface to clean everything up. And then we thickened our end result. Now for the last example here, oftentimes people will work with imported sheet metal parts. And depending on where that sheet metal part came from, you may have a cooperative or non-cooperative part. So we're going to open up this one here. We're going to say that this one was imported. And you may see a few things right off the bat. First of all, we are a surface body. We may want to be a solid body in order to convert into a sheet metal part. The other thing you may have noticed is that we have a few blue edges. So we have one down here, one over here, one over here. So like with any imported part, the first step we want to do is we want to run import diagnostics. We don't have any faulty faces, but it looks like we have about 10 gaps. Depending on where it comes from, you might have more, you might have less. Now, in this case, again, we're going to assume that import diagnostics cannot heal these gaps. In this case, I created the part in SOLIDWORKS, so it's likely able to heal those gaps. We'll just assume it can't. Now, it's going to be a bit of a pain to go around one by one creating surface geometry for every single one of these ones that went missing. So there's a neat little trick we can do using one of the rules of sheet metal in SOLIDWORKS. Any bend that you have on sheet metal is going to be perfectly tangent with its adjacent faces. So this means all of the faces on one side or the other side of a sheet metal part should be tangent. So I'm going to right-click any one of these faces and say Select Tangency, and it's going to grab all the faces on one side. Now what I want to do is I want to create a copy of these faces. So I'm going to go up to Surfaces, Offset Surface. Normally you'd use Offset Surface to, as the name implies, create an offset. In this case, I'm going to specify that offset distance as 0. So it is going to create these surfaces exactly where they are. It is essentially going to copy my selection as a new surface body. So we'll hit the green check mark. We now have two surface bodies. We have our original and we have our offset surfaces. We don't need the original anymore, so I'm going to do the same thing where I right-click, delete keep body. We're going to delete that body. All we're left with is the one I made the copy of. And at this point, it's pretty simple enough for us to just use the thicken command and re-thicken this part according to what the sheet metal thickness should be. And now we don't have to worry about recreating all of these little pesky faces that might have gone missing. And now we can do our last step under sheet metal. You can use either insert bends or convert to sheet metal. We won't get too much into those, but I'll select my fixed face, collect my bends, hit the green check mark. We see that we have a flat pattern folder, so let's check to see if we can flatten the part. So right up here we'll say flatten, and there's our flat pattern. So just to review, we made the assumption that import diagnostics could not repair our gaps. We used select tangency to grab all the faces of one side, and then copied those faces with a 0 distance offset surface. And then we thickened back to the sheet metal thickness and converted that to a sheet metal part so we could grab our flat pattern. And that's all I have for you guys. So if you have any questions, please let me or Chris know.
Great. Thanks, Braden. We do have a question from Dave, and he's asking, all this works on 2018. Is that correct?
So I'm using 2019, but everything that I went over works exactly the same in 2018. Yes.
All right, we got another question. Will it work in 2017?
Okay. As far as the versions go, there may be specific things like on the swept face, the merged tangent edges. I don't think that will go back too many versions. I know it should be in 2017, but if you go back far enough, I think maybe in 15 that option might not be there. For most everything else, it's pretty much the same between I'd probably say between versions 15 to 19, pretty much everything that I presented is going to be the same.
Excellent. We appreciate everyone dialing in today, and thanks, Braden, for a great presentation. If there aren't any other questions that you guys have at this point, we'll go ahead and wrap this up and let you all get back to your business.
Thanks, everyone, for watching, and if you need support, give us a call, and you might get me.
Thanks, everyone, for joining. We're going to go ahead and close the call, and we'll see you next time. Bye-bye.